Okay, another example about inclined surfaces. A car of mass 2 kilograms is on a frictionless ice driveway inclined at an angle 37, as you can see here. Show all the forces acting on the car, find the acceleration, and then find the normal force. Before that, as I mentioned previous in the previous examples, all the time, no matter what is your problem, try to have a diagram x and y axis showing or drawing all the forces acting on your system. But before that, I would like to mention this surface is a horizontal is is a, is the x axis. So the force here, as you can see, is parallel to your x axis. Okay, and from the previous, I think like maybe three or from the previous examples, we saw that the normal force here is perpendicular to this surface, but the weight has an angle. As you can see here, I have the normal force, I have the acting force, and the weight. But the weight here has an angle. So we have to have two components for this block's weight. So we have the weight along x-axis, which is mg sine theta, and the weight along y-axis, which is mg cosine theta. Okay, so part one is done. Now part two, to calculate or to determine or to find the acceleration, my advice for you, since you know the force, the magnitude of this force, which is 100 Newton, and you can calculate mg sine theta, which is 2 times 10 times sine 37, you will end up with 12 Newton. So you can determine in which way your object can go, either upward or downward. So since the force is greater than the x component of the weight, the object will go upward, something like this. Okay, now the acceleration, all the time to calculate the acceleration, we have to go to where is my object moving. So here it's moving along this axis, which is the x-axis. So we have to apply summation f of x equals max. And back to here, we saw that the force is in the same direction of the motion, and the x component of the weight is opposite on the opposite direction of the motion. So we can see, or we can write f minus mg sine theta equals ma. So divided by m, you will end up with, and substitute the magnitude of the force, mass, and the angle, you will end up with 44 meter per second square is the acceleration. Now to find the normal force, as I mentioned before, we are looking at the y-axis, and there is no motion along y-axis. So we can say summation or the net forces along y-axis equals 0, and we have only two forces, normal force positive, mg cosine theta negative. So we can say n minus mg cosine 0 equals 0, mg cosine 37 equals 0. Plug the numbers, you will end up with normal force equals 80 Newton. Okay, another example. In the figure shown below, if m1 equals m2 equals 2 kilograms, first show all forces acting on the system, and then find the tension on the string. Okay, here we have two masses. My system, I can split my system into two systems, M1 and M2. Now, my advice for you again and again and again, draw a diagram showing the whole forces acting on your object or your system. As you can see here, the first mass or the first block or box, there is a normal force perpendicular on it and the weight. Since we have string and the net force on the string equal 0, so we have a tension here to the right and we have a tension here upward and the weight. Okay, clearly from here this tension cancel out with this tension. Okay, this number one. Normal force cancel out with W2, W1, the weight of the first box. Therefore, the only force acting on the system will be W2. That's why the direction of the motion will be all the way down to the right. So to calculate the tension, since you have two systems or you split this system into two systems, you have to have two equations. Okay, I'll start with the first mass and the whole forces along x-axis, only one force, it's the tension. So that's why T equals m1 times A. Now let's go to the second mass and pay attention for the direction of the motion here. It's along y-axis. So we will have summation Fy equals m2A and W2, the same direction of the motion, will be positive W2 minus T equals m2A. Now I have two equations with two unknowns. For me, I like to add them together. Then minus T plus T cancel out. You can calculate the acceleration. Where is the acceleration from those two equations? Here equals 2W2 divided by m1 plus m2. You will end up with 5 meters per second squared, the acceleration. Now the question here is calculate the tension. So we cannot find the tension without finding the acceleration. Since we already have the acceleration, all what you have to do is just take equation 1 or equation 2 and plug the magnitude of the acceleration. So here I would like to use the first equation. It's easier for me and for you too. So the tension equal m1 times A. We know m1, which is given, equal 2 times the acceleration we calculated it. So it's going to be 10 Newton. Okay, another example. In the system shown below, if m1 equals 10 kilograms, m2 equals 40 kilograms, an external force of 100 Newton pulled m2 to the right. So here the direction of the motion is already given. Find the acceleration, then find the exerted force between those two boxes. Okay, since I have two objects, the best way is to have two diagrams as you can see here. Okay, now let me draw two diagrams, for one for m1, one for the second mass m2. Okay, I have the force here acting directly to m2, and I have the normal force and then W2. For m1 we have only forces along y-axis. Now let us go and look at the contact surface between m1 and m2. So here we have a contact force. As you can see, there is a contact force between those two boxes or those two objects. Sorry. Those two forces between m1 and m2, we have a horizontal contact force, I will call it E21, which is the exerted force or the force exerted by M2 on M1. Same procedure, we have another force exerted from M1 into M2. So we have E12 from the first mass to the second mass and E21. But those two forces or those two exerted forces are equally in magnitude and opposite in direction. That's why I call them E, because they have the same magnitude. You can call this one E12 or E21 and this E12. But by the end, they have the same magnitude because the net force here equals 0. Okay. To calculate the acceleration, same procedure. You have to say summation f of x equals, I will start with the first mass, summation f of x equals m1a, and I have only, for this one, I have only this force along x-axis. So E equals m1a. The second equation, which is F minus E equals m2a. And please remember, if the force has the same direction as the direction of the motion, it will be positive. If the force is in the opposite direction of the motion, it will be negative. That's why here the force is positive and E is negative for the second mass, and here E is positive for the first mass. Okay, I have equation number 1, equation number 2. Now, in those two equations, the acceleration and the exerted force, both of them are unknown. As I did in the previous example, I will add 1 and 2 together to then the exerted force here, positive and negative, they will cancel out. Then F equals m1 plus m2, all of them times a. So it's easy here to calculate the amount of the acceleration, which is F divided by m1 plus m2. F is 100, m1 is 10, m2 is 40. So 100 divided by 50 will be 2 meters per second squared. Now, to calculate the exerted force between those two masses, all what you have to do is go to equation 1 or equation 2 and substitute the magnitude or the amount of the acceleration. So we know m1, which is 10. We know we calculated the acceleration, which is 2. So 10 times 2, it will be 20 newtons. Okay. Another example, two masses, m1 equals 2 kilograms, m2 8 kilograms, connected by a light string that pass over a frictionless pulley. Light string, that means this string is massless and the net force on this string is 0. So determine the direction of the motion, show all the forces acting on the system, find the tension, then find the acceleration. Okay, to determine the direction of the motion, here you have to pay attention to the forces acting on the system. As you can see, there is tension here and tension here, as I mentioned in this diagram, and we have W2 and W1. But the tension here have the same magnitude and opposite direction, so they can cancel out each other. The only forces I can use to determine the direction of motion, either W1 or W2. But since W2 is greater than W1, the direction of the motion will be all the way to the right, downward to the right. Okay, show all the forces. So we have here W2, W1, T, and T. Okay, can I ask you one thing? What is the magnitude of the normal for the first and second block. There is no normal force. Why? Because I have no contact surface here or here. Find the tension in the string. Okay, as you can see here, my system, the direction of the motion of my system is along y-axis. So what we are going to do, take the summation of the forces along y-axis for the first mass. So this is the first mass. The tension here is in the same direction of the motion, so it's going to be positive. W1 is going to be negative because it's in the opposite direction of the motion. So we will have T minus M1G equals M1A. Acceleration and tension, both of them are unknown quantities. So we have to go to the second equation or the second mass to get the second equation. As you can see, W2 in the same direction of the motion and tension in the opposite direction. So it's going to be M2G minus T equals M2A. Two equations with two unknown. I will use the same procedure. So I will add them together. Then the tension here and tension here, both of them canceled out. So you will end up with the acceleration equals M2 times G minus M1 times G divided by M1 plus M2. Substitute the magnitude of the mass and gravity, you will end up with 6 meters per second squared is the acceleration. Now, to calculate the tension, you can use either equation 1 or equation 2. I'm sorry, here, not the acceleration, here the tension of each object. I'm sorry, it's typo error. So this should be the tension. So we are going to use either equation 1 or 2. I will go to equation 1, for example. This will be M1 times A plus M1 times G. M1 is 6. M1 is, I think, M1 is 2. 2 times 6 will be 12 plus M1G, which is 2 times 10. So here M1A plus M2 plus M1G. M1 is 2. 2 times 6, this will be 12. And 2 times 10 will be 20. So the tension will be 32. Thank you for today.